My name is Ed Lima, and I am a product manager at the AppSync team. We're here to talk about how to easily configure, deploy, connect, and secure multiple scalable, highly available, and flexible cloud services, as well as link them with user interfaces in different platforms with proper automation, best practices, and increased development velocity. We'll talk about different services and tools, such as the AWS AppSync and the Amplify Framework, and how they can make it easier for any developer to develop and implement full-stack serverless applications on AWS. First of all, let's define full-stack serverless applications. What is it about? Full-stack development refers to the development of both front-end and back-end portions of an application. If we're talking web development, the process involves all three layers: presentation layer, front-end part that deals with user interface, business logic layer, and a data layer. It's also important that you have a proper CI/CD process in place to automate integration, deployment, and delivery. A full-stack serverless app consists of a backend built with cloud resources such as GraphQL or REST APIs, file and data storage, and a front-end built-in with single-page application web frameworks such as React, Angular, or Vue, or mobile native platforms. So let's go through these different layers. The backend is where the user data and business logic which differentiates your app are in place. It's very important to authenticate and authorize users with proper access controls so they can only access what they have permissions to. You want to make sure users don't access data from other users and there is proper isolation and privacy in place. Other than that, it's important to implement some sort of analytics to understand how users are interacting with your application, user demographics, and how you can engage with your users to make sure they keep coming back to your app. It all happens under the hood, and you need scalable, flexible, and highly available services to provide these capabilities. The front end will provide the user interface from where users will interact with your app. It's essential to provide a great user experience. The user experience in the front end, along with the business logic in the back end, are the main differentiators to your business. They will make or break any application. With app applications, it's also important to make sure your application is hosted in a trusted global content delivery network that will make your application available with low latency to users across the globe. With the advent of PWAs, or progressive web apps, mobile and web apps are blending. You need to make sure your app will scale properly to different screens and devices. Finally, you need to have processes in place to automate and deploy features often and fast for both the front end and the back end. While the user experience is important for users, a great developer experience is equally important for the team building the app, so they can focus on features instead of operational issues, increasing development velocity. When developers commit code, automated processes need to take place to build and deploy the application in different environments where multiple teams can work together. How to develop, deploy, connect, host, and automate an application with all these moving parts and increase development speed following best practices? I'll show you how in the next hour. We're going to focus on serverless applications. With serverless, you don't have to worry about servers to provision, operate, or manage. AWS does that for you. You also never pay for idle, you only pay when your code's running. Scalability, high availability, and fault tolerance are built in. Join the serverless revolution. With serverless, you can focus on your application and your business differentiators, and not in the infrastructure to run your applications. You can focus on business logic code, and AWS maintains and runs all the code related to infrastructure, so you don't need to. The less time you spend on infrastructure maintenance and operations, the more time you can focus on new features and improving your application to speed up business outcomes. Let's start our full stack journey from the backend. APIs are a very important construct that connect your front end to the back end. Application programming interfaces allow applications to interconnect, interact, integrate with internal, external, private, or public services from all sorts. Making an analogy, imagine you and your friends are going out for dinner to a restaurant. You have a friend who is vegan, another one is pescatarian. I, for instance, like steaks. All of us have different preferences and requirements. When you get to the restaurant, a waiter or waitress brings you a menu with the specials, and you can also customize your meals. Maybe someone is allergic to seafood, so it needs to be removed from the regular dish. Also, the menu dictates what's available. You cannot go to an Italian restaurant and order sushi. The waiter or waitress will take your order to the kitchen with all customized options and requirements so the cook can prepare each meal accordingly. And in order to cook the food, the cook will need specific ingredients. It's very similar with applications. We'd have front-end clients as customers requesting a meal from the menu. The API server will be the waiter translating the client request and interfacing directly with the kitchen. The backend is the cook in the kitchen preparing the meal as per each client requirement, and the data stores will provide all the ingredients to prepare the meal. Let's take a look at the building blocks of an API. This is a very basic API that could also fit perfectly as a microservice in a distributed system. One of my colleagues here at AWS like to put it as the new three-tier architecture of modern days. Of course, you can evolve and enhance the API with failover capabilities, load balancers for resiliency, message buses, and other types of workers. Now, bringing this stack to the cloud, we'd have the exact same constructs. You could basically lift and shift an API from the data center with little effort. On AWS, you can adapt and enhance the API, choose cloud-native features, and bring important capabilities such as auto-scaling and multi-availability zone to the mix, thus improving elasticity and scalability. Same as before, you can add more complex capabilities depending on your use case. In the serverless world, we'd have serverless APIs, serverless business logic, serverless databases, and no need to worry about provisioning, patching, maintenance of servers, or load balancers. High availability, scalability, and fault tolerance are built in. You can still add message buses, queues, streams, and workers to your API backend for more complex use cases. When you talk serverless APIs, in AWS there are two main technology choices: REST or GraphQL. One is not better than the other. They have strengths and weaknesses. You can definitely use them together in different parts of your application, and they are both excellent when used for the right thing. I am a firm believer on using the best tool for the job. You don't build a house using just a hammer, and it's the same with distributed systems and applications. I believe a picture is better than words to describe one of the main advantages of GraphQL. Let's imagine you have a blog post application. In order to fetch data to populate my front-end user interface, I need to make a call and get a list of posts and post IDs. Then I use one or more of those IDs to retrieve comments, so I need to make a second call. Then, if I need to get information about the authors, I need to make another API call to a third endpoint. In order to get the data that I needed, I had to make 3 API calls because I was either overfetching or underfetching data. With GraphQL, I only have one endpoint and I only need to make one single API call. The data is retrieved from multiple data sources automatically for me. And these data sources can be anything: SQL, NoSQL, HTTP, it doesn't matter. We can also make an analogy with pizza. With REST, you order a pizza and it comes with all toppings. You have to remove them later. That's overfetching. With GraphQL, the pizza comes just with the toppings you requested, nothing more, nothing less, which means it saves you time and bandwidth. So GraphQL, as the name describes it, is a data query language for APIs. It is also a runtime to fulfill those queries. It's very important to notice GraphQL is not a graph database. GraphQL is expressed as a declarative language for requesting data from your application's backend. It uses a type system that allows you to understand data requirements and get meaningful error messages, making it easier to use and prototype. You define a GraphQL API with a schema based on a schema definition language, or SDL. The schema is where you define different types, such as user type and its properties of fields, like you can see here. Using something called introspection, a client can retrieve the schema and automatically understand how the API is documented. In our restaurant analogy, you can think of it as an easier way to get the restaurant menu to order your API goodies. In this schema, you also define specific operations. There are three types of GraphQL operations: queries to read data, mutations to modify or write data, and subscriptions. Subscriptions are linked to mutations and allow to send real-time notifications to subscribed clients whenever data is changed by a mutation. GraphQL looks awesome, right? But how's the best way to use GraphQL in AWS? Well, we could run a GraphQL server, but servers are so 2014, aren't they? With AWS AppSync, you can build scalable and robust applications over GraphQL with both real-time and offline capabilities. Best of all, no servers to worry about. AppSync is a managed serverless GraphQL service, perfect for interacting with application data. It connects to resources in your own AWS account, allowing to make your data available in real time or offline. It can be used as a GraphQL facade for any AWS service. It also allows to perform conflict detection and resolution in the cloud instead of doing it in the client. AppSync integrates with AWS Identity Access and Management, Cognito user pools, and you can use external OpenID Connect providers or even API keys, providing really powerful options to secure, authenticate, and authorize your GraphQL API calls. So let's see it in action. So here we have a really cool tool, it's called OneGraph, right? You can connect to different services. I'm logged into my Spotify account, and I want to interact and search for instance, a specific artist. There's this band from Australia, I really like it, it's called Wolf Matter. And I want to actually get information about the name of the albums from Wolf Matter. As you can see, I can get and model the data that my client needs, and I can I just need to add specific fields, right? And here I want to know all the tracks for each album, so I just add that to my query, and I'm connecting to the exact same endpoint. And those queries, they could be connecting to different data sources as well. And I can model my data according to the client. How does it work in AppSync? So in AppSync, you can create easily a GraphQL API. You can import from a DynamoDB table, or you can create with a wizard. So let's create a new API. So let's create a cars API here. And we have, for instance, some fields like a brand, a model, color of the car. Just model my data, and then I create my API. I just name, it's going to be my cars app. So the wizard is going to create a DynamoDB table and build all the logic to interact with the DynamoDB table. And just takes a couple of seconds. And just like I was doing with OneGraph, I can interact and query my data straight away. So here I can start making mutations and creating data. So I'm going to create my first car. Is a Subaru Outback. And let's say color purple. I just issue my mutation and create the data. Let's create a second car. Say a Volkswagen Beetle. Then I have a color red, and let's add a third car. A Honda Fit, color black. Now I can query the data I just created. So I can list all the cars that I just created. So I'm interacting with my application, and I also have what I mentioned as introspection. So it's in that restaurant menu analogy, it's an easy way to understand the format of my API. And I can also model my data. I can remove the fields. Let's say I just need the ID and the brand of the cars. That can easily be done at any time with GraphQL. So this is what I created. I created a cars type, but as you can see, the schema was expanded and added some utilities, all the operations to perform CRUD access to my DynamoDB table. I also have some helpers there to perform filtering. And here, that's how I interact with Dynamo. AppSync has the concept of resolvers. So I can create those resolvers and I can modify them. And there are also built-in resolvers that I can use. Here's my data source, is a DynamoDB table. If I go to my Dynamo table, then I'll be able to see all my cars there. So I managed to create an API backend in minutes with a very powerful database and a very flexible API technology. So who is using AppSync in production? We have customers such as Ticketmaster uses AppSync to provide live information on available seats for events and venues. IDT Telecom provides communications and payment services to help people stay in touch and share resources around the world. IDT uses AWS AppSync in their cryptocurrency, peer-to-peer wallets, and money transfer services. PrioSec delivers end-to-end security solutions for serverless applications. They use AWS AppSync to provide their customers with real-time updates on the security of the serverless apps. Virgin Trains collect high-volume data from multiple real-time data sources, and AppSync delivers to their customers. CookPad's serverless architecture with AWS AppSync delivers automatic scale to support real-time chat and engagement during live shows. ACBL uses AWS AppSync in their infrastructure for service-to-service communication and in their proprietary internal front-end applications. It's important to understand AppSync is first and foremost an application data service with real-time and offline features implemented over GraphQL with additional capabilities such as built-in authorization and conflict resolution. It's not simply a GraphQL API proxy. You can have all sorts of applications, enterprise, mobile web, IoT apps, accessing a GraphQL API powered by AppSync to interact with different data sources in your account. Applications securely connect to an AppSync GraphQL API to access and combine data from different data sources, other APIs, or backend systems. These data sources can be DynamoDB, NoSQL tables, Aurora serverless databases, or Elasticsearch clusters. AppSync APIs can access any AWS service using Lambda functions or even REST APIs, including regional endpoints for other AWS services with HTTP resolvers. Like I said before, you can easily have both REST and GraphQL on your backend. It's also possible to use local resolvers. Think of it as a pub-sub channel where data is not persisted. In order to start to use AppSync, you need to define your data model with a regular GraphQL schema. Resolvers, as we saw in the demo, provide the link and logic between the types and operations from a GraphQL schema and the data itself. You can think of them as a glue connecting the data types and operations in the schema with the related data sources. They are very important construct essential to connect AppSync to your data. Resolvers allow to add specific logic using request and response mapping templates. You can use them to modify the data before and after it reaches your backend. When the client invokes a GraphQL query, mutation, or subscription, you can use a VTL or velocity template to modify the request before it gets to the data source. Maybe you need to add specific parameters or use utility helpers to validate the payload, creating identifiers, or validating conditions before reaching the backend. The transform request then reaches the data source to perform the operation. After the operation takes place in the data source, you can also have a response template to modify the data on the way back to the client. In some cases, applications require executing multiple operations to resolve a single GraphQL field. With pipeline resolvers, we can compose resolver operations, also called functions, and execute them in sequence. You can orchestrate different use cases, for instance, perform an authorization check before fetching data, or write a transaction to a separate location before sending data to a database. In this example, a pipeline function connects to the user table to check the user profile, if it has admin rights. If so, it will allow to access another table with the posts owned by the user. All of that in a single GraphQL call, orchestrated by a sequential pipeline. One of the most important capabilities in AppSync is built-in support for real-time data. For instance, you could have a Lambda function in the backend retrieving data from an external source, such as a public API, then sending a mutation to AppSync that will update a connected data source, for instance, a DynamoDB table. You can have thousands of clients subscribe to that specific mutation on AppSync, receiving a broadcast with the updates as soon as they are written to the table at the same time. You can also have clients interacting with each other, sending and receiving real-time events in many-to-many scenarios. AWS AppSync takes advantage of GraphQL subscriptions to perform real-time operations by pushing data to clients that choose to listen to specific events from the backend. This means that you can easily and effortlessly make any supported data source in AWS AppSync real-time, with connection management, fanout, and broadcasting all handled automatically by the service and the AppSync client SDKs or Amplify clients, using WebSockets as a network protocol between the client and service. Basically, when the client invokes a GraphQL subscription operation, a secure WebSocket connection will be automatically established that will remain constantly connected to your backend. We released our first real-time reference architecture earlier on this year. It includes sample code that helps you understand and apply best practice to your next collaborative real-time application development project, showcasing a backend broadcasting data to multiple clients as well as clients interacting with each other in real time. Best of all, you can try yourself with one-click deploy to the Amplify console. But I might be getting ahead of myself. We'll talk about the console later. AppSync also has built-in offline capabilities. If you are using a mobile app and for some reason you get to a place without coverage, such as a tunnel or a subway, the AppSync client can use optimistic UI features to enable users to keep using the app, adding and editing data. When the client gets back online, the data is automatically sent to AppSync and update the backend data source. You can also enable Delta Sync, where only data that was changed is updated instead of the whole dataset, and configure conflict resolution strategies. A very powerful use case for AppSync: you can retrieve or modify data from multiple polyglot data sources, such as GraphQL and NoSQL with a single call. Query and create relations between data sources using GraphQL connections. Provide real-time and offline capabilities to web and mobile clients using AWS AppSync as a GraphQL data layer over disparate polyglot backend data. You can also use AWS AppSync as a single interface to connect and aggregate multiple microservices in your application. AWS AppSync can act as a data layer and interface to connect and communicate seamlessly with multiple microservices in your application, even if they are running in different environments. For instance, on containers in a VPC, a REST microservice on Amazon API Gateway, or behind the GraphQL on another AppSync API. Now let's talk about some important features we recently released on AppSync. One of my favorite features we released this year is called local mocking. You can run a local version of your AppSync GraphQL API in your laptop, speeding up development and easily allowing you to test, prototype, debug, and generate code with no need to wait for resources to be deployed to the cloud. You can also have access to the Amplify Graphical Explorer, where you can introspect the schema types, look up documentation or any field or type, test API calls, or prototype your queries and mutations. Best of all, when ready, you can deploy the local environment to the cloud with a single command. When AppSync was released, you could only have a single authorization mechanism per API, either OpenID Connect, Cognito User Pools, IAM, or API keys. Some people had to duplicate APIs for public and private access, as it wasn't possible to mix and match different authorization providers. Now you have a global authorization mode, however, you can add multiple additional authorization providers. The most powerful capability is to be able to assign specific providers to different types or even fields in a type. For instance, I can have a type in my schema where most fields can be accessed with an API key. However, the user must be authenticated to have access to an email field, for instance. Best of all, you get partial responses, allowing the client to access only the data it has permission to access. As you can see in this example, the email field in the API JSON response comes out as a null. However, I still have access to the data on all other fields. If I authenticate my user using Cognito User Pools, in this example, I'm signing in with a user JDO. the email is displayed accordingly. It's great as I can define fine-grained security directly from my data definition types, fields, or operations in a GraphQL schema. We also release integration with CloudWatch log insights, allowing you to get very useful information about your API usage. CloudWatch logs insights enable you to interactively search and analyze your log data in Amazon CloudWatch logs. Best of all, there are useful, simple queries that allow you to get started in no time. In this example, I can access the most frequently invoked operations and resolvers in my AppSync API. It helps me understand and identify hotspots. In this other example, I can easily identify latency stats in specific fields and operations. Since it's all stored in CloudWatch logs, I can stream the logs insights to an Elasticsearch cluster and create useful dashboards to understand the health and operation of my GraphQL API. We talked about a very powerful, scalable, and flexible API backend. Now let's move to the front-end part of our full-stack journey. How to make it easier for front-end applications to connect and interact with your scalable API backend. Last year, we released the open-source Amplify Framework, which provides a set of developer tools, libraries, and UI components, as well as a powerful command-line interface to build and manage cloud backends, easily integrating your iOS, Android, web, and React Native apps. The framework provides an easy-to-use library allowing to interact with cloud services with few lines of code, a powerful toolchain that allows you to create and manage cloud services and backends. Finally, it also provides reusable high-order UI components, allowing to accelerate development for your app. Other than the CLI and libraries with native and JavaScript support, there's also a powerful console that simplifies continuous deployment and allows you to automatically build and host your app application in minutes. Let's take a closer look at different parts of the framework, starting by the CLI toolchain. The CLI allows you to easily create, update, and delete different cloud services. It also supports multiple environments so you can have development sandboxes and shared environments with a team of developers. Finally, there are powerful built-in GraphQL tools to easily integrate and manage your AppSync API backend. The CLI provides different intuitive categories that you can mix and match in a single Amplify project. These are self-descriptive categories such as authentication, analytics, chatbots, APIs, serverless backends, file storage, augmented or virtual reality, push notifications, video streaming, or predictions powered by AI/ML services. The toolchain uses AWS CloudFormation and enables you to add, modify, and share configurations. After you create a local project using the CLI, you can use simple commands to add, delete, or configure categories. The commands automatically generate CloudFormation templates based on a couple of questions asked during the category setup. After you have all the categories you need added to your project, you just need to run Amplify push to automatically deploy the generated CloudFormation templates, automatically spinning up the cloud services in minutes. In my opinion, one of the most powerful CLI tools is the GraphQL Transform. The GraphQL Transform provides a simple-to-use abstraction that helps you to model your application data and quickly create backends for your web and mobile applications on AWS. As a type system, you just need to define main types for the data in a GraphQL schema. Let's imagine I have a specific GraphQL type for my data in a blog post application, for example. I just need to add the API category using the Amplify CLI and add the type definition I need for my app. The transform uses directives that you can associate with types or fields in the GraphQL schema. Each directive can do different things. Add model creates and configures DynamoDB backends. Add connection allows you to create relations between DynamoDB tables. Just think about it for a moment. Relations in NoSQL. That's very powerful. Add auth automatically adds authentication and authorization. Add searchable allows you to stream data through Elasticsearch. Add version adds a version field and conflict detection to your model type. Add function allows you to easily integrate a Lambda function to your GraphQL API, and add key enables you to configure custom indexes in DynamoDB. Very useful if you want to set up a single DynamoDB table for different types. But how does it work? You just need to define a data type or multiple types in the GraphQL schema file. The GraphQL transform allows me to use specific schema directives in my data type. If I include the @model directive and push the changes, a CloudFormation stack creation is started and a GraphQL API pre-configured with all the necessary CRUD, create, read, update, delete logic, and a linked DynamoDB table is automatically created in minutes. However, this might not be enough, as API calls are authorized only with API keys. How can I improve my security posture and have a proper identity provider authenticating and authorizing my calls? It's as easy as adding another directive, @auth, with specific rules. In this case, I just want the user that created the data to be able to access and modify it. Alternatively, I can specify groups, such as an admin group, for instance, that can have extra access. After I commit the changes and update my backend with a single command, a user directory based on a cognito user pool is created and automatically configured to authenticate and authorize calls from my API. Now going one step further, I have a serverless scalable API powered by a serverless database and user directory that provides me with authenticated CRUD access to my data. What if I need to add search capabilities to my backend? For those not familiar with Elasticsearch, configuring and installing a cluster can be challenging. What if I could do it just by adding one extra line to my API type definition? That's exactly what's possible with @searchable. I just need to push my changes once more, and an Elasticsearch cluster as well as the DynamoDB streams and a Lambda function are all deployed and configured automatically, handling the data synchronization between DynamoDB and Elasticsearch. So as you can see, with a few CLI commands and a couple of schema directives based on GraphQL transformers, Amplify CLI created a very powerful, secure, highly available, flexible, resilient, and scalable backend in minutes, where users can be authenticated and authorized with @auth, then create, read, update, delete, and list data with @model, as well as perform full text search with @searchable on that same data very easily and very fast. Best of all, the whole backend is managed by AWS, and you don't have to worry about any maintenance or operational tasks. After the GraphQL API and the data backend is deployed, CodeGen helps you generate native code for iOS and Android, as well as the generation of types for Flow, JavaScript, and TypeScript. It can generate GraphQL statements, queries, mutations, and subscriptions so that you don't have to hand code them. Finally, with the CLI, you can create, manage, and connect to different environments in the same project. With multiple environment support, you can use Git-style interaction and project switching, as well as share backends with teams or create a fully isolated sandbox for your specific development needs. So you just learn how you can quickly create cloud services and backends for different use cases by mixing and matching CLI categories and using the GraphQL transformer to create and manage powerful GraphQL APIs. However, after my backend is in place, I need client libraries in my application to access and interact with the newly deployed cloud services. Now it's time to move up the stack. Let's take a look at the Amplify client. The Amplify client provides opinionated and declarative libraries focused on specific client use cases, providing abstractions with best practice built in to access the services deployed with the Amplify CLI. We'll focus now on web development. Let's take a React app as an example. We just need to install the Amplify client using npm, then separately import one or more specific categories we want to use in our application code. For instance, if all I need is integrate some authentication logic, I just need to import the Auth module and interact with my Auth backend with simple self-descriptive calls. For instance, auth.signin to sign in a user, or auth.currentAuthenticated to get specific information from the authenticated user. The user data is managed in the cloud by the cognito user pool created by the Amplify CLI. The Amplify client supports native platforms such as iOS and Android, and different JavaScript frameworks such as React, Vue, and Angular. You can also use built-in higher-order components to accelerate development. There are different components for file storage, authentication, and chatbots. In this example, You just need to import the with-authenticated component and wrap your app React component with it. 2 lines of code, and you have a built-in component with sign in, sign up, reset password, and forget password logic out of the box to secure your application. Amplify provides an opinionated way to create, configure, and manage your cloud resources. However, there might be times where you need to go beyond and customize the backend in different ways. Amplify provides escape hatches where you can customize different resources such as custom transforms, custom resolvers, as well as you can add your own CloudFormation templates. Other than that, the Amplify client can call methods on any AWS service interface object supported by the AWS SDKs. Now let's go through a practical example. Imagine I need to build an app that needs to sign up and authenticate users, connect to both REST and GraphQL APIs, then integrate analytics to understand how users are engaging with the app. I can do all of that with AWS services. However, it could take a couple of hours to manually create the resources and link everything together. Let's see how we can use the Amplify CLI and the Amplify client to do it in minutes. So this is the workflow you'll follow. We deploy a REST API, authentication, a GraphQL API, and then integrate analytics. First, I use the CLI to create an API, select REST as an option, and answer a few questions to select the serverless Express backend. Notice the icon in the corner means we are executing an AWS Amplify CLI command. Here, the icon is different. It means we need to go to our IDE and add some code or modules from the Amplify client library. The CLI created a Lambda function with boilerplate code in a local folder where I can customize and add my own Node.js code. I execute the Amplify push command, and my REST API and serverless Express backend are automatically deployed. Let's imagine I'm using React for my front-end client. I just need to import the API module and define the calls to the REST endpoint with few lines of code. Now I need to secure access to my app. I only want authenticated users to access my backend. I'll quickly add a full-fledged user directory powered by a Cognito user pool provider with a single CLI command. Back to my code, I import the Auth module from the Amplify client and implement the authentication logic with simple sign-in or sign-up calls. Alternatively, I could just have added a high-order component with a single line of code with all the authentication logic built in. Moving on to the GraphQL API, I go back to the Amplify CLI and add another API with a single command. This time I select GraphQL as my choice. I define my data. Let's imagine it's a to-dos app. Adding the GraphQL transform directive add model will automatically create a backend DynamoDB table and as an AppSync data source. Next, I push my changes to deploy all the backend services I configured in the previous steps. Cognito user pools, where I manage my users, an AppSync API with CRUD logic built into DynamoDB are all deployed and configured for me automatically. Back to the React app, I import the GraphQL operation module, and you notice a list to-dos object. This was automatically generated by Amplify Code Gen during my last push, so I don't need to worry about writing my GraphQL query code. I can then use api.graphql with the important list to-dos query to retrieve all the to-dos from my DynamoDB table with few lines of code. For the last piece of the puzzle, I need to add analytics to my app. 2 simple commands to set up and deploy an Amazon Pinpoint project. I import the analytics module to the client and set up the events I want to record with an analytics.record call. Imagine it's a music app and I click the button to listen to a Rage Against the Machine album. I can quickly add some analytics capabilities to a button press event with a couple of lines of code. And here we are. With little more than 10 steps between the Amplify CLI and the Amplify client, I was able to deploy a backend with different APIs, analytics, and user management, and link it all together with security and best practice built in minutes. I didn't have to spend much time deploying high scalable and robust serverless services or integrating it with my front-end code. With the Amplify client, I was able to intuitively interact with all those services with few lines of code. Most of my time as a developer can now be spent on the actual business logic and the user interface that will differentiate my application, allowing me to focus on features that will bring the most value to my business. We talked about amazing backend and front-end services, framework, clients, and tools. But in order to deploy and deliver my full-stack serverless application, I need to make sure I have the right automation in place with a proper CI/CD process. Let's take a look how we can do it. When we're talking DevOps for full-stack applications, we need isolation between projects and stages. Source code is the source of truth and should be always available. If you can have both front-end and back-end code in the same code repository, it's less likely there will be version mismatches. Most important of all, developers are in control and deploy both front-end and back-end. We have to recognize that there might be some level of coupling between front-end and back-end. However, there should be flexibility where you can share back-ends between team members as well as the option to have sandboxes for isolated development that will not affect other branches. There are lots of challenges we have to consider when deploying web apps. There are faster release cycles. It's common to release several times a day. We also have to consider team workflows in different development environments. Finally, we should be able to deploy your web app globally so it's available in a reliable content delivery network for users anywhere at any time. That's why I released the Amplify console to address all those requirements and common challenges. The Amplify console accelerates your application release cycle by providing a simple workflow for deploying full-stack serverless applications. You just connect your application code repository to Amplify console, and changes to your front-end and back-end are deployed and built in a single workflow on every code commit. Your application is built and deployed automatically as soon as there are any code changes detected in the repository. You can easily configure custom domains and automatically host your application across multiple points of presence globally. The console also is aware of different branches, and you can password protect the app for testing. All successful deployments are available immediately after an update. Failed deployments do not impact production traffic. Amplify console is perfect for full-stack serverless web applications, static sites generated by Hugo, Jekyll, or Gatsby, as well as progressive web apps which offer mobile native-like performance, work offline, and can be updated over the air to mobile devices. So let's take a look at another demo. So here I have an application on GitHub. It's called Hypebeats. It's a beatbox, and as you can see, it is an Amplify project. So I have a Amplify project initialized on my laptop, right? I cloned that repository, and as you can see here, I have an API in a create state, so it was not deployed to the cloud. And I can see my backend is all detailed according to a sample, to a GraphQL schema. So my data is all module, and there's an add model directive where I'm going to save data to DynamoDB. I can also add and test Lambda functions. So here I'm going to add a Lambda function called fact of the day. I'm going to use a basic sample, and I'm just going to paste my code. So because I have some extra dependencies like Axios and Moment, I'm going to install those libraries on my Lambda folder. And I can also test my the Lambda function I just created locally. So I'm going to do just that. Just need to provide a couple of information, answer a couple of questions, and there we go. I get here the fact of the day. I'm just accessing the numbers API to retrieve that data. But how can I actually link that to my GraphQL API? So for instance, I can create another field to my type on my drum machine. Fact of the day, so it's a string, right? And with add function directive, I just point that to my Lambda function. So every time this field is queried, I'm going to invoke my Lambda function and I'm going to get the data from my external API. But I can also mock my API locally. Again, I haven't deployed any of this to the cloud yet, right? So when I mock an API, my DynamoDB table is going to be stored locally as well. It's going to be used at Dynamo Local. It was created by a DynamoDB team. And you can interact with that local DynamoDB table. And my API is also going to be available locally. So I can just access the Amplify Graphical Explorer. And very similar to OneGraph from the first demo, I can basically build my queries and I can start creating data here. So let's imagine I'm going to create a drum machine here and I'm selecting the fields I want to return. I'm returning my Lambda field as well. As you can see, my Lambda function was just trigger and returns the fact of the day. As I'm not persisting that data anywhere, I just getting the data from Lambda, I'm just getting a new fact of the day anytime that I call Lambda. And same as before, I have my menu, right? I have introspection where I can actually understand the types in my GraphQL schema. So I could run Amplify push and deploy that environment to the cloud with just one command and also generate code with CodeGen, but I'm not going to do that. Let's deploy my app using another way, a CI/CD way. So I'm going to go to GitHub, where the code is. Again, it's an Amplify project. And I can one-click deploy to the Amplify console. So it's going to connect to the Amplify console. I'm authorized to access my GitHub account using Auth. And I also need to define a role. That role is going to have permissions to create all the backend resources. So it's going to create a fork of my repository and then start creating my app. There you go, you can continue, and now the build process is going to start. So it's going to provision the build environment, right? And then after that, it's going to build, deploy, and verify my app. But it's going to take a couple of minutes. As any good cooking show, I had the app already ready to go. So as you can see, after it's deployed, you're going to see something similar to this. So you can see the steps to deploy the backend, the front end. You can log all of this, you can test. And you can also verify how the app looks like after deployed. It's also automatically hosted. You can create custom domains as well. So here I'm just going to the generic Amplify app domain, and I can access my my app. So this is, like I mentioned before, is a drum machine. But it's a real-time drum machine, so I can interact and collaborate with other people using GraphQL subscriptions. So I'm just going to put two instances of my app side by side. As you can see, I'm accessing my app from the internet. It was deployed to very powerful CDN, where I can access with very low latency. And because I'm using subscriptions, I don't need to reload the app. So I'm going to create a new drum machine called Reinvent. So you can see it shows up on the other client automatically because of subscriptions. And there you go, I have my, my drum machine. and I can start playing music and collaborating. I could have hundreds of people accessing this drum machine and making music together. As you can see, as soon as I click in one instance of my application, the other instance sees the exact same interaction. So it's all done in real time using WebSockets and subscriptions, all managed by AppSync. This is the end of our full-stack journey from the backend to the front end and CI/CD. We took a look at a very flexible and resourceful API technology, cloud services, tools, a framework, and a very powerful console. All of these services help to increase development velocity, including local mocking, then deploying and configuring highly available and scalable cloud resources in minutes, as well as providing a flexible client to interact with your cloud backend so you can focus on what truly differentiates your app: the business logic and the user experience. No need to worry about things like infrastructure or servers, as they are not related to your app's core business. Before I go, I'd like to share a couple of useful links. Amplify is open source, and we'd like to develop and build a community to share ideas, content, and foster interaction with developers. We also have our AppSync community repository where you can access articles, content, tutorials, and sample code. Please check the links and share your ideas, feature requests, and give your opinion on our RFCs. Our AppSync and Amplify roadmaps are strongly based on our customers and developers. What do you want to see next on AppSync and Amplify? Create a feature request in our GitHub repos and let us know what else we can do to help you be successful with your next application project. Thank you very much for spending this time with me. It's been a pleasure and always great fun presenting at re:Invent. Go build with AppSync and Amplify.